Before we can get started on the main work for question 3 in Unit 10, we need to address two slightly tricky issues. First, which is the first payment of the 10th month? In the first month, there are 12 payments. In the second, 12 more, making 24 altogether. In the first 9 years, there are 12 times 9, or 108 payments. The very next payment, the 109th payment, must be the first payment of the 10th year. So the payment we're talking about in this question is the one 109 months from today. The second tricky point is that the problem tells us our money grows at 6.25% annually. This 6.25% is not a simple interest rate like the one used in calculating the mortgage. So we can't divide it by 12 to get a monthly rate. We do need a monthly rate, though, because we'll be following money month by month for 109 months. To convert an annual amount, an annual rate, to a monthly rate, we must use goal-seek. Here are the calculations. We start with a round amount of money and a guess for the monthly interest rate. We follow the money month by month for a year. If $100 grows at 0.5% per month, then here's how it will grow over the course of the whole year. Half a percent monthly turns out to be the equivalent of 6.17% per year. What's the equivalent of 6.25%? We use goal-seek to find out. At 6.25%, the final amount would be $106.25. To get it there, we change the monthly interest rate. And here's our answer. This precise monthly interest rate, rounded off to 0.51%, is the same as an annual percentage rate of 6.25%. Now we can answer the main question. In this mortgage, as we noticed in the main question, we pay the same amount each month, $1231.43. Our first payment is that amount, the second payment is that amount, and 109 months from today, we can be sure that we will owe the bank precisely $1231.43. The question asks for the present value of that amount. That is, how much money would we need to have now, set aside in a bank account, so that we would have precisely the right amount to pay 109 months from today? Suppose we set aside $500 and watch it grow for 109 months. Each month it grows at the monthly interest rate that we've calculated, the one that's equivalent to 6.25% per year. Over the whole 109 months, our original $500 would grow to $867.21. But that's not enough. We'd like to have enough in our bank account to pay $1231.43. So we'll need to set aside more at the beginning. If we set aside a different amount, $710, then that would be precisely enough to grow to $1231.43 at the end of 109 months. The payment of $1231.43 109 months from today costs exactly the same as a payment of $710 to a savings account today. That's its present value.